All right, we're about to uncover a hidden mathematical pulse that, believe it or not, secretly powers almost everything in our modern world. I'm talking about the music you listen to, the light you see, pretty much everything. So let's pull back the curtain and trace the incredible journey of this hidden rhythm.
So just think about that for a second. Sound waves, alternating current, digital images. On the surface, they have absolutely nothing in common, right? But what if I told you they're all connected by the exact same fundamental idea?
Yep. The answer isn't something you can hold in your hand. It's a concept, a beautiful, repeating pattern that was figured out ages ago, and it has become the literal blueprint for our entire technological age. So today, we're going to trace its amazing story. To get to the bottom of this, we've got to go way back. And I mean no modern labs, no computers. We're talking about ancient astronomers just staring up at the night sky. And they had this massive puzzle on their hands. How in the world do you map the heavens? How do you predict where the planets are going to be using just geometry?
Okay, so the first big breakthrough came out of ancient Greece. To connect angles with distances, astronomers like Hipparchus and Ptolemy came up with something they called the chord function. It's pretty simple, really. Just picture a circle and then draw a straight line between any 2 points on its edge. That line? That's a chord. This was a huge first step, the very first system for tackling these cosmic math problems.
And you really got to hand it to this guy, Hipparchus. He's the one who actually sat down and created the very first tables of these chord values, laying the entire foundation for centuries of discovery that would follow. For a long time, this was the bedrock.
But here's the cool thing about great ideas. They rarely stay in one place. This concept wasn't just owned by one person or one culture. Nope. It was more like a torch being passed in a relay race across the globe, getting tweaked and improved with each handoff.
So, you can see that whole journey laid out right here. It kicks off in Greece with the chord. Super useful, but a little clunky. Then the torch goes to India, and this is where a brilliant simplification happens, a real game changer. From there, Islamic scholars became the crucial link, preserving and building on this knowledge before passing it on to Europe, where it got polished into the slick, modern functions we use today.
And that moment in India, that was the big one, the real aha moment. Indian mathematicians, especially a guy named Aryabhatta, realized it was way more efficient to just work with half of the chord, or Ardha Ja. Now, this might sound like a small change, but it was massive. It shifted the whole concept from being just about a physical length to being a super versatile ratio, which is the very definition of our modern sine function. And get this, here's a great little piece of trivia for you. The name itself is kind of an accident. See, when all this work was eventually translated from Arabic into Latin, the word ja got mixed up. The translator thought it was a similar sounding Arabic word and wrote down sinus, which is Latin for bay or fold. And boom, just like that, a simple mistranslation gave us the name sine. Crazy, right?
So for hundreds of years, sine and its buddy cosine were just tools for geometry, figuring out angles, measuring distances. But their story was far from over. Their true destiny, their secret identity as the language of waves, was about to be revealed.
And this is it. This is the big reveal. Because when you actually plot the values of the sine function on a graph, you don't just get a boring line of numbers, you get this perfect, beautiful, endlessly repeating wave. This shape is called a sinusoid, and as it turns out, it's literally everywhere in nature. This is the moment trigonometry stopped being just about triangles and became the fundamental language of physics.
All of a sudden, these functions weren't just about static, boring triangles anymore. They were the key to everything that moves, anything that repeats or vibrates or oscillates. It's really not an exaggeration to say they became the mathematical description of the rhythm of the universe itself.
And once that door was opened, wow, it unleashed a tidal wave of new uses, changing our world in ways those ancient stargazers could never, ever have dreamed of. I mean, just think about it. The sound waves carrying my voice to you right now, described by sine. The light and radio waves that make wireless communication possible, all sine waves. Even something as massive as the ocean tides, or as simple as a swinging pendulum. It's all following that same beautiful mathematical beat. For engineers, this stuff is an absolute superpower. Sine and cosine let them take any force that's pushing or pulling at some weird angle, what they call a vector, and just break it down into simple, manageable pieces. How much of that force is going straight up and down, and how much is going left and right. It makes incredibly complex problems, like building a bridge or coding a video game engine, totally solvable.
And you don't have to look far to see it in action. Just look at any power outlet in your house. The alternating current, or AC power, is created by spinning magnets inside a generator. And guess what shape that process naturally creates? A perfect sine wave of voltage. That steady rhythm of electricity in your home is pure sine.
Okay, now let's bring it right into our digital lives. Ever wonder how a huge, detailed photo gets squeezed into a tiny JPEG file? It's done with a totally mind-bending trick called Fourier analysis. The core idea is that you can take any complicated signal, a picture, a piece of music, whatever, and break it down into a bunch of simple sine and cosine waves. We're literally using this ancient idea as building blocks for our entire digital world.
So, what a journey, right? It started as a tool for ancient astronomers trying to figure out the stars. And now? Now it's the fundamental blueprint for modern engineers to describe literally anything that wiggles, rotates, or repeats. It's just an amazing example of how one single, pure idea can ripple through thousands of years of history and change everything.
It really makes you think, doesn't it? What other simple, ancient discoveries are embedded in the technology we use every single day, just hiding there in plain sight, waiting for us to notice? Something to think about. Thanks for listening.